Okay, I've just started the recording. Please feel free to use the chat throughout the presentations. I have team members that will be looking at the chat and providing comments where necessary. At the end of each presentation, we will be having questions. To participate in the questions, just feel free to put your hand up, and whichever appears first on my screen will go with them. All right, so let's get into things. So first, the acknowledgement of country. I'd just like to pay respect to the traditional owners of the land, the past, present, and emerging. I'm currently undertaking this presentation on the lands of the Dharawal people, and feel free to use the chat to indicate where you're currently attending from. So today's presentations are about providing a balance between the risks and the benefits of generative AI, and we look at a multitude of platforms. We will start off with assessment integrity, and we will be highlighting some of the benefits, but you will see that Gen AI is something that will not go away, and it is being used more and more by the community. So AAIEEC, or A squared I, E squared C, is a special interest group of the Australasian Association of Engineering Education. We were formed in December, and we currently have 4 research clusters looking at ethics, project, work integrated learning, and programming. Hopefully in the future, as the membership grows, there are potential for a research thesis cluster and a laboratory cluster. Our main form of communication is via a LinkedIn group, which is available via searching for this. We currently have over 125 members. And then if you come along to our website, you can officially join to become an official member. And we're currently sitting at over 50 members. All right, that leads us to our first presentation, and that is the battle between generative AI and assessment security, which is something on the minds of most academics in higher education. We're doing this looking at 3 most popular platforms, which is ChatGPT, Microsoft's Copilot, and Google Gemini. The reason why we chose these is that we had limited time frame to look at all possible Gen AI models. But in addition to those 3 models, we've also looked at the Wolfram and SciSpace GPTs, and GPTs is OpenAI's wording for plugin. All the information presented in my talk is going to be available in this paper here that will be published in the Australasian Journal of Engineering Education as open access, hopefully in the next few days. It's currently waiting final proofs. So my guess, somewhere between Monday to Friday next week, it should be available. Anyone who is registered for this webinar, I will email you the link, and that will provide the full details of the presentation. Today, I'm not going to get into too much technical. The idea is to present to you as many practical examples, just so you can open your mindset to what is available and capable out there. So this research is done by a multi-institutional team where we, as subject coordinators, looked at the impact of Gen AI into our different subjects, and we did this by applying it to all our assessment tasks. Now, this is not a new process. We actually did this at the beginning of last year, and this paper here has already received over 28,000 downloads. So it's had huge impact in the community. And where we were at the moment, back last year, was that GenAI was slightly better than engineering education assessment. These were found to be fairly secure. These were found to be a tie, and this is where ChatGPT 3.5 was really good. Now, if you take a look at the image of DALL-E's capability a year ago to the capability of DALL-E today, you can see a huge difference. And it also led to the difference in performance. So the ability of engineering education assessment to win is down to only 2 assessment tasks. We remain a tie for 2. Written research has come over across to the GenAI side, and the performance on quizzes and numerical assessment tasks has improved substantially. We just need to keep in mind that everything that I mentioned today is already out of date. Our benchmark study in Q1 last year, it's already prehistoric, and our current study is already showing signs of wear and tear. Think ChatGPT 4.0 and all the latest releases from other GenAI platforms. Now, most of what we're talking about is going to be summarized in this table here. It's table 10 in the AJE paper that I will email out to everybody. And what we do is we provide a comprehensive analysis of your short-term, long-term assessment security options to secure your assessment, and as well as opportunities of how to integrate GenAI into your classes. I'm not going to be covering everything in this presentation, just a few of the selected topics, but again, feel free to come to our paper once it's published to get that comprehensive look of all different assessment types. So we start off with the online quiz. And if you look at the performance back in Q1, you do see that performance was pretty okay. But now, when we look at the new tech, especially ChatGPT 4, the results have increased substantially. And you can see there's a mix of performance between the different GenAI technologies. And that really comes down to what was the requirement of the quiz, what was its target, what was its content area. So the different platforms do perform in different ways based on their training. Now, when we released that first paper, we said short-term, the performance of security could be enhanced by using lots of figures and tables. That would slow students down in online quizzes. And when we presented that first paper, image uploading wasn't possible, but we knew that it was coming and we knew it was going to be a threat. It has become a good tool, but it's still not good enough yet. So this is still a short-term security option. Longer term, there's going to be 2 possible choices when we're talking about high-stakes assessment. And everything I talk about here is going to be overly simplified. To get the specifics, the details, you'll need to refer to our paper. But basically, long-term, if you want to use an online quiz, you're going to be looking at running it in a supervised environment. Now, we can use stuff like Proctorio to check, or enhance security, but there are increasingly a lot of papers in the literature showing ways of how you can beat such invigilation software. So we either get students into the lab, supervise them to complete their tests, or the alternative is we make sure that our online quizzes are designed in a way where GenAI integration is allowed. So they're going to be allowed to use GenAI when they're completing their online quizzes. And that's the most long-term solution across the board. Now, I want to give an example of what it's like using image recognition. So when we uploaded this circuit here to find the current, it was able to do it. This circuit here, it wasn't able to. Same with this determining the shape factor. However, recently, ChatGPT moved to 4.0 and we were able to do some quick analysis. And again, it got this correct. Now it was able to upload, analyze, and get this circuit correct. This one here, it struggled with still. However, if we look at the question and we look at the first stage, when it came to determining the volume of the smaller cube, it was able to do that. But when it came to determining the volume of a larger cube, it got a little bit confused. And beyond then, next steps of the calculations, it started to get things wrong. However, when it came to ChatGPT 4.0, it was now able to analyze the top and the bottom correctly. Where the problems came in is in the further calculations. And this is something that I'll discuss in a future slide going on. But we just need to be aware that in less than a year, how much progress image recognition has made. Now, there is some shortcuts, some security options. And one is if you allow the students to use Gemini, if you incorporate an image of a person within the question, Gemini will tell you, sorry, it can't analyze the image. However, if you try and do that with ChatGPT and Copilot, because solving the equation doesn't require looking at the image, both will be able to find the current without a problem. However, if I asked it to find the expression of the face when it comes to ChatGPT, ChatGPT doesn't care if there's a face there. It will analyze it and tell you what appears. But what Copilot does is for any faces, it blurs it out and it isn't able to analyze the image. So next we move on to numerical assignments and exams. These are problem-solving questions that aren't a simple answer. They require multiple lines of working. And when we looked at ChatGPT 3.5, it was able to pass a lot of assessment tasks, but it did so not by getting the final answer correct, but by giving students lots of marks on the working. So it was making a lot of progress, but it was pretty much always getting the final answer wrong. Now, this has completely changed with ChatGPT 4, and the performance is completely dependent on the topic. And again, I'll refer to this in a future slide. The way to increase performance is via the Wolfram GPT. As you can see, in most cases, the accuracy improves when you're using Wolfram. The disadvantage of Wolfram is it doesn't provide as much information and guidance to the student as using the ChatGPT. So one way around it is if a student has an exact question, the best off using Wolfram to find what the correct answer is, coming back to ChatGPT 4 and getting that detailed description that can help them learn if that was the objective. Again, what you see is we can improve security short-term by using images and tables. And again, no surprises, long-term security option is a supervised, no GenAI integration option, or changing our assessment tasks so the questions involved GenAI integration. So in terms of performance, I want to show you of something that we're going to be presenting at Cefi. What we have done is we've looked at the capability of ChatGPT to act as a tutor. And the key to any tutoring is to make sure that it can provide accurate and reliable information. Now, you don't need to worry too much about what this table says. The key thing to realize is that 4 means it didn't make a single mistake. 1, 2, and so forth means it made mistakes along the way. And as we can see for integration, it makes a lot more mistakes than it does for the multivariable chain rule. It makes lots of mistakes for Bernoulli's principle, but when it comes to psychometric chart, it made no mistakes. So obviously here, what we're seeing is difference in training. And this is something that we're going to provide a more comprehensive list in an upcoming journal paper. But we just need to be aware, different topic areas, different performance from the different platforms. Next comes experimentation. And what we have is experimentation is good, but our weakness at the moment is that a lot of the focus is on reports. And anything that's text-based GenAI has a huge capability of helping with. So the short-term security option is to make sure that you're not repeating experiments year to year, which allows for simple paraphrasing and enhancement. But really what we need to do is move away from reports. Long-term, what we need to do is remove the focus of face-to-face labs from the cognitive domain. Cognitive domain is good for remote simulation, virtual laboratories. They've been shown to be equal or better performance in improving cognitive learning. When it comes to face-to-face, we really need to take the advantage of focusing on the aspects that GenAI can't do, and that's psychomotor and affective learning. The problem with this is shown in this graph. Now, this is too small for you to see, and that's done on purpose. But basically what we have here is different assessment types and different cognitive learning objectives. The top row is if it's an implicit verification or an explicit verification. This is the combined. So basically what we're saying here is for this learning objective, all the different assessment types verify this objective. So think of a traffic light. Dark green means we are confident that that can be verified. Red means we are not confident that this assessment type can verify this competency. So what we're seeing is lots of green, and this is for cognitive objectives. However, when we move to psychomotor and affective objectives, as an academic community, we have little confidence in that our assessment types can verify the different objectives. And this is something that we're going to have to work on if we're going to be able to shift our focus in laboratories. Next comes to reflective and critical thinking based assessment tasks. And what you will see in most cases, GenAI does a great job. Where it failed was where the analysis was video-based, because currently most of the technologies can't analyze video, but this is something that's coming across into the future. Now, I want to provide some quick examples. One here is of Copilot. If you tell it to use a specific method to answer selection criteria, it can do that pretty well. And something that Copilot is good is it can actually give you multiple suggestions to think about and improve your output. Another example is using Gemini. Here I put a very, very basic prompt to provide me a reflection on my experience attending a guest lecture. And it acknowledges that it's a pretty bad prompt, and it provides you with a template. Now, this is shortened. There's a lot more advice given at the end, but it's just to highlight that the technologies can help students pass their assessment tasks. Another thing that we've been seeing a lot of are recommendations that we provide students with a GenAI output, and we ask students to critically analyze that information. Now, what we need to do is we need to think about, is that supervised or unsupervised? Because if it's unsupervised, here is a very, very basic prompt, but I can get GenAI to pretend that they're a first-year student and provide that critical analysis. Another thing that people have been doing is saying, let's use track changes. Again, this is the most simplest prompt that one could write, but it can add track changes into its solutions as well. Short-term reflections need to be added with a portfolio of evidence. Long-term, you know the story already. Next comes written research-based. And what has happened back in ChatGPT 3.5 is that it was really weak because there's lots of bad writing, bad references to literature, lots of hallucinations. However, now when we include GPTs like SciSpace, all those weaknesses disappear. And in fact, if you go to YouTube, there are many very detailed walkthroughs of how you can use such plugins and ChatGPT-4 to write a complete introduction, literature review, almost perfectly. So the capability is there. And in fact, using SciSpace to find research of relevance is actually very useful. I've started using it myself because you can really pinpoint something. So you can say, I'm looking for a lab-based study that looks at interview type assessments, and it will find it. It'll give you the titles, it'll give you an insight which you can click on. It will take you to the SciSpace external tool where you can download information, do extra analysis, but most importantly, you can upload the file into ChatGPT and analyze it against any framework that you would like. Copilot is very good for information that doesn't require scholarly literature because it provides lots of references so students can validate the information, and it also helps them scaffold their thinking. Short term, there are pathways that you can use, most specifically to use a structure that's non-standard, that's much harder to prompt. Longer term, we need to think about what we're asking for in terms of research. How are we going to assess research? And more importantly is, who are the role models? Being published are evidence of GenAI being used within publications. And GenAI is excellent at helping people write introductions and summaries and so forth, but we need to make sure that we are doing things in the right way. And that brings me to the end. I'm just going to skip through the rest. Just a reminder, full detail is going to be available in our full paper being released next week. Final note is that assessment is only one part of the equation, and we need to be aware of that. There's quick one or two questions available should somebody like to ask it. Please feel free to put forward your hand if you have a question. Yes, Hamish.
Thanks, Sasha. Given the speed at which things are constantly changing,
Yep.
do you feel there is a lot of how much value is there in actually starting a project and doing research on these things when by the time we finish the project, it's already almost useless?
Listen, it's a difficult question to answer because it's going to come down to your learning objectives. Okay, but ideally, long term, what we need to do is we need to think about is how can we create an assessment task where students using Gen AI to assist them is a given. That is the only long-term solution.
Thanks, Sasha.
Thank you. Shannon, you were next.
Hi, Sasha. Thanks for the presentation. It was really good. Just a quick question more about the logistics of the study. When you got it to attempt these quizzes, tests, problems, whatever, and you used the different models, did you do multiple attempts with each model, or was that just like a one shot, one attempt response?
Yeah, so the full methodology is in the paper,
Yeah.
but the idea was, what was the minimum prompt that would get it over a pass? Okay, so when it was a black and white answer, like numerical questions, you know the answer, we went to what was the score that it could achieve. For anything that's subjective, such as marks in a project, it was simply pass or fail. We've lost your voice. You muted yourself.
I was saying, it sounded like what you're saying is you adjusted the prompt until you got it to work.
That's right.
Yeah, okay.
Yeah. Helen, last question before we move on.
Thanks. Thanks, Sasha. Thank you to you and your co-authors for the wonderful work that you're continuing to do. As we've discussed before, I think it's really important work. So thank you. My question is around, what do you think? And you know, this is a big question, so feel free to take it on notice. But what do you think is the most important thing an academic can do right now to prepare for the future? And what do you think that future looks like in 5 years?
It's same as answering in Hamish's question. We have to accept that whatever we do in terms of assessment security will be short term, unless it's a supervised assessment. Now, everything can't be supervised. We have to accept that there's going to be a lot of unsupervised assessments. And for those unsupervised assessments, we need to be prepared to find out how those assessments can be integrated with Gen AI use.
I guess I'm talking more about what the academic can do, regardless of assessment. What's the critical thing you think they need to do to change their practice, regardless of whether it's assessment or is that identifiable or?
Well, I'm going to oversimplify this, okay? But our focus, and when I use the laboratory example in case here, is that our focus has heavily been focused on cognitive learning. We now present the opportunity of thinking about what is it that Gen AI can't do that humans solely can do. So for example, as in laboratories, you've got your psychomotor and affective skills. We may need to start shifting our focus. Like, so that's a simplified answer, but it's something that I can say in 30 seconds or so.
Terrific.
Okay, thank you very much. So we now move on to our next presentation, which is by Zach and Kathy on GenAI and Ethics.
Thanks, Sasha. Zach, you there? He's there in situ anyway.
I have too many screens and too many buttons. All right, cool. You should be able to see the PowerPoint now.
Yes, can do. Fantastic. Thank you so much, Zach. So thanks everyone for attending today's webinar. I just wanted to give you a quick update as to one of the little subsections that we're doing. There's a group of us, myself, Zach, Scott Daniel, Ruby Michael, Emily Faulkner, and Sasha, who are looking at the ethical use of generative AI as well. Next slide, please, Zach. So with this particular project, we're trying to investigate how people are going to be using Gen AI in an ethical way. We're looking at the perspectives of academics, industry, and students alike, looking at how this might be used. We started with thinking about what are the concerns of generative AI as far as an ethical issue is concerned, and how we might be addressing these sorts of issues throughout our field. Next slide, please, Zach. So the project itself, we started with a systematic literature review, and we thought this was probably the best place to start to find out exactly what's happening in the universe at the moment. Then trying to look at the gaps that were there to see whether or not we could do any further exploration, and then we wanted to do some comparisons between how we think the ethical use of generative AI should be and how we're actually using it. Zach, next one, please. So how's it going? Well, the good news is that we're almost through to the full paper read of our systematic literature review. The bad news is there's very little out there. Now, this is problematic in some senses, but in other senses, not necessarily. It just means that we're thinking about things before other people have done so. So what we're doing, we will continue and complete our systematic literature review. Like I said, there's lots of people wondering whether or not we should or shouldn't, but we're going to complete that before we start to think about what our next steps are. What we're hoping our next steps will be is that looking at doing some empirical data analysis of how the different groups use generative AI and how the ethical approaches could be put forward for that. And then, of course, we have our final stage, which Zach will talk about a little bit later on, identifying student awareness, so the social, economic, and environmental implications of using Gen AI, which is still in review. Next slide, please, Zach. So where do we go from here? Once we complete the systematic literature review, we're then going to move on to gathering data from academics, students, and industry professionals. We want to ensure that we cover all three bases, because if we can't understand how industry are going to use it or the ethical implications of industry, then we can't teach our students to be really good engineers. We also want to then combine the findings from both lots of analysis and hopefully with a view to publishing that. We're also looking then at where we can go from there. What sorts of things are we going to need into this universe when we're looking at generative AI and the ethical approaches for that, and how do we emphasize the usage of this in an ethical standpoint. I'm going to hand it over to Zach now. He's going to talk to you more about our third stage because he's a little bit further ahead with that. So Zach, thank you so much.
All right, thanks very much, Kathy. There was just one more slide, which I will just quickly cover off. And that is that the team will be presenting a workshop at A2E2 in Christchurch, New Zealand this year, where we're going to have a look at the ethical considerations around the utilisation of GenAI in engineering education, the perspectives of both students and academics about the ethical use, and we're going to investigate whether the current ethical guidelines are actually sufficient or if they necessitate a redefinition based on the technology. So today I'm going to be going over the project that myself and Sasha have been working on, which is having a look at the perceptions of students with respect to the use of GenAI. So what we did is we have a project that basically incorporated ChatGPT into an early assessment item of a course. We wanted to understand the perceptions that students had about using GenAI in their study and practice. However, to make sure that there was enough substance to the project, we also put a critical thinking spin on the approach. There were 64 students from all 4 year levels. It happened in early 2023, and it occurred at the UNSW in a course that focused on technology, sustainability, and society. So, you know, the ethical considerations of using ChatGPT is it's a very good course to fit into. So the project kind of had 2 aims. The first one was to identify the student perceptions of the ethical implications of using GenAI, specifically ChatGPT. And then also, to what level can ChatGPT be used to apply critical thinking? So the assessment consisted of 2 distinct parts. It was part A and part B, where part A, we asked students to assess a ChatGPT generated essay. And then part B, we asked students to write a reflective essay about the implications of the use of ChatGPT in both their study and in their engineering practice, whether they are currently practicing or whether it's their future. We asked them to write a reflection on that. The pedagogical approach was, in part A, we wanted them to have a look at what an acceptable essay is. And then in part B, we wanted them to do a research-based reflection. So we asked them questions where they would have to go and do research about ChatGPT. Now, there was an explicit instruction between part A and part B that says you will have to go and do research before you can provide your reflection. However, the approach also looked at whether students were able to implicitly go back to part A once they have done their research in part B and then improve part A. To go a little bit more into depth, part A, the essay was actually generated using a very, very simple command prompt. It was used on ChatGPT 3. And the reason that it was used with such a simple prompt is because we wanted it, one, not to be perfect. We wanted it to have some flaws. And we also wanted students to be able to improve upon that input prompt to see if they could start trying to develop the use of ChatGPT and GenAI. So the approach basically sought to get students critically thinking about what looks good. So to do that, and also to kind of address the perceptions and to make sure that the implicit and the explicit instructions were occurring, we asked the students 5 questions for part A. So most of these came down to, how was the information provided? Was there any points of misinformation or unreliable data? So this was back at the start of 2023 when ChatGPT was creating references, was creating information that came out of nowhere. So we were expecting students to kind of know that or be able to quickly find out that information. We then had a look at the style of the report. Does it follow the structure that we've taught students in class? So critically analyze the output, having a look at the referencing and making sure that the sources are correct. That was one of the big ones because this was implemented into a second year course. So students might not have had a great deal of going and looking for references and trying to find correct literature. So we wanted to make students go and try to have a look at that reference, see if it's real, see if the information is contained within it. And then, as I said, we wanted to see if we could get students to have a bit of a play with ChatGPT and see if they could rephrase the input for a better output. For part B, students would write a reflective essay about their use of ChatGPT in their studies and industry. We gave students the explicit instruction that they had to undertake research such that they could make actually an informed reflection. And part B was a little bit more open-ended, where we only asked them 3 questions, which was, where is it likely to be used in your chosen discipline, and whether you think it is going to be positive or negative. What impacts do you see it having on your study life? Again, positive or negative. And where are you most likely to use the program in the future? So to answer the research aims, we needed to see if students were able to undertake the explicit and the implicit instructions. And we also wanted to obviously gain their perceptions on what topics within GenAI they were looking at. So what we did is we scoured the literature for some themes or some topics that incorporated social, economic, or environmental implications of the uses of GenAI. And we came up with 32 possible themes. What we did is to figure out whether there was an explicit and implicit process happening. We would map individually students' assessments, tasks A and tasks B. And then we would see if there was if there was more non-duplicate topics referenced in part B than part A, we could show that there was the explicit learning happening. However, the implicit was a lot harder to try to gauge and figure out whether students undertook that. And what it kind of came down to was we decided kind of if the number of topics is the same between part A and part B. So the idea is that you would have a limited amount in part A to start with. You would then do your research, increase that in part B, and then the implicit feedback would make you go back and talk about more topics and strengthen part A. What we ended up with was figure 2 is the number of identified implications by students in parts A and B. So as you can see, there is a lot more orange than there is blue on that graph. In part A, students were on average only identifying approximately 2 themes in the entirety of part A. Whereas when we get into part B, we saw that there was, the median was 5. So we can see that there was a lot more topics, being examined by students in part B. So this was definitely showing that there was an explicit learning happening. Figure 3 shows the percentage of unique identifications for each of the implication codes. So this is separating basically part A and part B and looking at overall which implication codes saw the most unique identifications. As you can see from the table, there are definitely a few that kind of spiked above that 50%. And the 2 that were above 80% was C31, which was understanding subjects, which basically referenced that ChatGPT was able to understand engineering. And 90% of students were mapped that particular topic. And then the other one that was over 80, which was 83%, was C6, and C6 was competitive advantage. So when students were undertaking their research, they could see how powerful of a tool GenAI actually is with respect to their study and industry. Figure number 4 saw that there was almost 100% identification of topics at some point in Part B, which was really excellent to see that everybody was kind of referencing those topics. However, in Part A, it was a little bit more lacking, and we only saw that students were identifying about 2/3 of the themes that we had identified. And as you can see, C25, C29, and C30 were all mapped 0 times across all of the students' Part A and Part B, where those related to privacy, security against misuse, and transparency and accountability. What was interesting to see is that Table 2 showed the topics that were not covered by more than 5% of the cohort in either part of the assessment. What I personally think is kind of frightening is that students are not thinking about the data security, the data ownership, or the data collection of GenAI at all. There is 3 topics there that were not mapped basically at all. And all of those have to do with the information you're putting into GenAI, as well as what they're doing with it, how they're outputting stuff. So it was kind of scary to see that students weren't thinking about this at all. However, it wasn't really surprising that students weren't thinking about this. The surprising one for me was feedback, which was C18. So students weren't able to identify that GenAI was good for feedback, which in my opinion is one of the really good and strong parts of GenAI is that you can talk to it, which means that it should be able to converse. You should be able to get feedback out of it. And there's definitely been a lot of studies showing that, it can be used for feedback as a tool. So it was interesting that students didn't really see this. The other thing that was really a really good outcome of this study was that students were, once they did their research, they were no longer looking at ChatGPT or GenAI as the solution. They were thinking about it as a tool, and they were thinking about how it could help them rather than it's going to replace me or it's going to do all the work for me, which was an incredible outcome, because one of the ideas from this project was to get students familiar and accepting of this new technology, because there's no getting rid of it. So overall, the project, I think, was a great success. Students were able to identify some very specific ethical implications, which was bias, understanding the subject, competitive advantage, able to automate processes. So very much what at the time GenAI was very much in the limelight for it's going to help everything. And then what we found was that students were not able to identify privacy, security against misuse, and transparency and accountability. And the transparency and accountability one is, again, when we're talking about ethics, not a great one. So we definitely need to make sure that we're teaching students that. And the second aim was, to what level can ChatGPT use to apply critical thinking skills? There was limited awareness gained directly from the critical analysis in Part A. Future implementation should maybe broaden the scope of the questions, or maybe make it a little bit more iterative and a little bit more hands-on, rather than it just being, here's a task, go do it. Students didn't recognize the ability of the implicit feedback loop, which was not surprising. We did see 1 or 2 students actively able to use it, which was good to see. But the biggest thing that we saw out of this project was both activities work together to give better insights, rather than it just being, have a look at this and give me a breakdown, or whether it would just be a reflection. Both of those 2 activities work together. So based on the success that we saw in this research project, we're currently implementing the same approach to an engineering management course where we're specifically looking at applying Gen AI to engineering practice in the areas of the Engineers Australia Code of Ethics, personal accountability, safety, and law. That wraps up my talk today. So now I'm going to open it up for questions, assuming I'm not running over time.
Let's give 5 minutes for questions. Just please put your hand up if you have a question.
Can I have a quick question, please?
Yes.
Thank you so much. It's an excellent presentation. I'm just very curious about that part you mentioned. Students take a look at ChatGPT as a tool rather than replacement. I would like to have a little bit about that one because it's my interest. Thank you.
Okay. So basically what we did, the reason we did the positive and negative in terms of asking students what they thought was there was a lot of media attention at the start of 2023 that basically said that, you know, Gen AI is bad, it's going to destroy everything, it's going to take all the jobs. So we wanted to see kind of what students thought of that. And when we had a look at their responses, there was a lot of responses that said pretty much the same thing, which was, I thought Gen AI was really bad because of what I've seen. However, when I've gone and done my research and I have used it, I have found that it is not, you know, this perfect solution or perfect replacement, that I'm just going to be able to use it to automate things and to make things more efficient. Specifically in the engineering discipline, the things that kept getting noted were, I'm going to have it write my schedule, I'm going to have it communicate to clients, I'm going to, you know, have it write reports, proof documents, all of these type of things. So students were able to kind of have a look at it outside of I think is what academics kind of thought students were thinking of it as, this is the way that I'm going to cheat, this is the way that I'm going to get through this, this course is I'm going to get Gen AI to do everything for me. And it was good to see that the mindsets shift from students to Gen AI is now a tool. This tool is going to help me, but it is not going to do the work for me.
Thank you so much.
Is there any other questions? If not, thank you very much, Zach and Kathy. We move on next to Farham and Hamish on from University of Sydney on project work.
Hamish, sorry.
Right. Thank you, Sasha. Let me just set my camera up so that it's not blocking anything. Okay. All right. So thanks, everyone. Our little project that we started last semester was basically on changing some of the engineering project approaches by integrating not just artificial intelligence, but design thinking elements to enhance the applicability for the user. And you'll understand in a second what we mean by that as we go through design thinking. Some of you might already be incorporating this into your project work. But diving in here, so what do we have inside in this presentation is we'll talk a bit about why we started our project, and also what our assessment, or rather the pilot assessment, looked like before we made any changes. We'll talk about why we decided to make the changes in the first place, and then we'll go over design thinking, how we incorporated design thinking elements, artificial intelligence, how we needed to reevaluate the assessment based on these the incorporation of design thinking and artificial intelligence, what the outcomes look like, and where we want to go from here. All right. So our project initially started because we noticed after discussions with various schools, different schools across the Faculty of Engineering, that there were two key issues with some of our projects. One being students seem to want to go straight into the design phase. They came up with all these intricate designs, really well done designs, but sometimes, or in many cases, without truly spending enough time on understanding what the critical needs of the user is exactly. All right. And the other problem was the students had this funny relationship with AI. A lot of them used it, considered it almost cheating in all cases, even if we were allowed to use it. And there are some people who've, in our previous Use It conferences, we talked about how even if the students were allowed to use AI, it's so connected to kind of academic integrity issues that they didn't even want to admit it. So it's almost something that they used sneakily, all right? Whereas other students used it, knew it wasn't cheating, but they didn't understand how to use it appropriately. So we decided to kind of change up our projects a bit, starting with a pilot project in one of our units by incorporating design thinking frameworks to centralize the user needs and to add strategic guidelines on how to use AI throughout this design thinking process. This was enabled by some funding that we got by the University of Sydney, a strategic education grant, and was supported by an external advisory group, because a lot of the things we were doing in this project were relatively new to us, all right? So we needed as much help as we could get. So in addition to about 7 members within the Faculty of Engineering in the University of Sydney, we did get a lot of assistance from academics and industry experts nationally and internationally in running this project. All right, so the traditional assessment in the pilot, what did it look like? So we've only run the pilot so far, okay? Now, this is actually my unit that I ran in the School of Biomedical Engineering, and it's called Data, AI, and Society in Health. Now, this is a second-year elective unit, but although it's second year, because it's 2925, it actually had students from their first year all the way to PhD students. Okay, so there was a large range of background skills and knowledge and competencies. And with regard to the content, it wasn't just technical coding skills, but we also talked about business aspects, we talked about management aspects, and very importantly, some of the social and ethical aspects of AI use, as well as data analytics. Now, the change was created within the pilot in the major assessment, which was called AI implementation in healthcare. This essentially involves students having to develop an AI tool or a system which addressed a particular problem within a healthcare organization. That's it in a nutshell. Now, traditionally, this involved students coming up with a hypothetical healthcare organization. So they think, oh, maybe I want to help an orthopedic surgical department or surgical theater within some hospital somewhere, all right, maybe an urban hospital, okay? And then they'll start doing online research. They'll go through literature, they'll go through newspaper articles and just do online research, basically for the entire assessment. So their entire problem is based on what they look at online. Then they come up with their solutions based, once again, on their learnings in the unit, as well as online research, traditional assessments. Now, the design of this was not really, it wasn't designed to emphasize the problem. The students had to come up with a problem, true, but it was mostly online research. So they're not actually connecting with stakeholders here. So do they feel that this is really important? Okay, do they feel that they need to connect with the stakeholders and understand all the different problems that they're facing in order to come up with their solutions? Okay, they end up spending weeks just doing research, writing, fine-tuning. And also at the end, when they send us the report over, we just mark their report. What did they do in order to get to this? We can see some references. We can tell what a good, report might be. But what did the students actually do to come to that? All right, so why did we want to change this? Okay. First of all, of course, the AI revolution that we've all been talking about, we had to change it because, of course, students could just use AI. If a student was very savvy with AI use, they could just write the whole report using AI. Okay. And of course, we don't want that. And also, we wanted to emphasize the importance of understanding the problem, all right? So I want the students to understand that truly connecting with the stakeholders here is critical. And by doing these two things, or by changing the assessment to address these two things, these 2 points, we could actually give the students some valuable graduate skills, competencies, and opportunities, all right? So we could actually create networking opportunities through this assessment. We could get them to work on some soft skills, as well as, importantly, in this environment, make them comfortable, okay? Create a sense of comfort with using different AI tools for different processes, All right. So the first thing that we implemented here is a design thinking process. A design thinking process is a way of approaching project work, innovation, product design with the human at the center, with the user needs at the center. So with regard to this assessment, what we did was the design thinking in this case was an iterative process. It always is. You can go back and forth between the different stages. So across the 9-week timeline of their project, they were introduced to these different stages, and they were taken through that process step by step. Okay. So in the first 4 weeks, we spent on the empathize phase of the design thinking. All right. So that is, they needed to really connect with the stakeholders. I'll tell you how in a second. All right. But it was mostly about connecting with the stakeholders. All right. Weeks 4 and 5, we spent on problem definition. All right. So once they connect with the stakeholders, understand their problems, now you're going to define some of the key problems that you're going to deal with. In week 6, they spent on ideation. Once you have all that, ideating, you can spend less time on that, because the most important, beautiful part about this process is already done, and we spent most of our time on that. Now, remember, this is iterative. They could go back and forth, okay? But that's how we broke it down within our assessment. And of course, we got the prototyping and testing phase, given that they didn't actually have to come up with the tool in the end, because that wasn't part of the outcomes for this unit. That was more just in their written report. They needed to come up with that in a hypothetical sense. All right. And the key reason we did this was because there's actually a lot of evidence. I've added 3 references here, which I'll show you at the end, that design thinking does truly help students tackle complex engineering problems in a more human-centered manner. All right. Introducing AI. So this was the beauty of this whole thing, okay? Because it was completely open to AI use. You could use AI for any aspect of this assessment, even writing, okay? We had some checks and balances in place there, which I'll talk about in a second. The assessment scope was transformed to far more about the user needs. And the reason we were able to do this was because the efficiency, okay, the efficiency and the productivity, because the students were allowed to use AI for any aspect, we essentially were allowed to buy time, so to speak, to actually connect with stakeholders. So now what the students need to do is not just do online research, they needed to reach out to stakeholders themselves to organize interviews or set up questionnaires, which means they needed to now call up or communicate with people through their networks, or even send cold emails to the orthopedic surgeon or the orthopedic nurse, all right, or patients who have been in the orthopedic surgical department, all right? Then they needed to design their questions and the questionnaires or the interview questions themselves. They needed to actually perform the interviews. They needed to do their research before and after in order to get some background information before the interviews and verify some of the information they got after. And they needed to actually analyze this information formally, okay? And they could use AI for any of these steps. So therefore, like I mentioned, the major emphasis was on understanding the key issues prior to getting into designing or even ideating, okay? And students could use AI for any of these steps. So they could use it for drafting emails. They could use it to design interview questions. They could use it to get us set up transcripts for their interviews when they were doing the interviews. And they could even use it to conduct lit reviews, all right? So we used AI tools to actually conduct lit reviews as well. Again, there were checks and balances in every step. Why? Because in this case, we were assessing the process over the product. Okay, so it wasn't just the final report we were marking. Because this assessment was so different compared to previous semesters, and maybe possibly I would say even your traditional units, your unit assessment outlines, we needed to help students along the way. So they needed a bit of hand-holding, okay? So we gave them a detailed roadmap of, hey, if you want to finish this in 9 weeks, here are the things you'd want to focus on each week, okay? And so with this roadmap, each week we spend 30 minutes of our tutorial time, okay, for our 2-hour tutorial time, dedicated to how they could go about that particular checkpoint for that week, as well as how different AI tools could be integrated to help them with that checkpoint. And we actually did we worked on examples, okay, sample scenarios during the tutorial. 2 of these checkpoints were marked in weeks 4 and 6. By week 4, we expected them to have actually been able to communicate with some stakeholders or at least made a good attempt to. There are some students who definitely tried, but they couldn't get anyone. That's fine. I want to see that you made an attempt to actually make this communication. And by week 6, we would have at least liked them to have completed 1 or 2 of the interviews or sent out 1 or 2 of their questionnaires. Okay, so those were key checkpoints. And these 2 checkpoints accounted for half of the total mark of this assessment. They also had to post screenshots of key references in the appendix because they were allowed to use AI tools. We needed to verify that, hey, they didn't just believe everything the AI tool gave them. They actually followed up and checked and verified the information in here. So they needed to highlight the key points that they got from the reference, take screenshots and post it. Yes, they had a reference list, but let's face it, a lot of us don't have time to go through an entire reference list. And when a student posts a screenshot, even if I didn't go through every single one of those screenshots, it's like they're kind of exposing themselves almost, right? So it's almost as if, hey, you might look at it, it's right there. So I'd better verify everything here. So it was more of a way to push students to make sure that they're verifying everything. All right, the assessment outcomes, a lot of this is still pending because we did send out a student reflection, all right, at the end with a lot of interesting data that we've collected, but we haven't actually analyzed that yet at this point. However, there are a few things I can say. The quality of the assessment, it was way better than last year. It is incredible how much better the assessment reports were. So much so that in order to meet, these their requirements from Engineering Australia, I suppose, and not have everyone get like an HD, I had to actually become more strict with my marking. So I can't really compare the means, unfortunately, between last year and this year. All right. Now, here's what I really liked, and this is just from what I know. Again, I haven't actually gone through the reflections yet, but this is what students have come and told me. Now, there are 4 students that came up and told me that their stakeholders, okay, generally in healthcare organizations, really wanted to read their assessment, okay, and we talked about how that could be done. 2 students, at least, okay, from the students who came up and actually talked to me, actually got internships and or other job opportunities through their connections with these stakeholders. And at least one has organized an honors thesis project for her thesis next year. Now, looking ahead, what we'd like to do is we'd like to now take all this information we've gathered from the pilot through the student reflections, as well as further discussions with academics around AI, as well as industry experts within AI, and also research of available literature to add value to projects around the Faculty of Engineering and the broader University of Sydney through a variety of ways. First of all, create a Canvas page that actually details how to utilize AI for various stages of DT, of design thinking. That way, other academics and coordinators don't have to spend time they'll have to spend less time actually going over all this during their teaching process, because it'll all be there. There'll be a series of documented pages in text form, as well as videos. So students, when they're doing design thinking projects, okay, or projects in general, can go and look at it themselves. That way, academics don't have to worry about, hey, how am I going to find the time to teach them all this? We're also going to create an AI agent, a cognitive AI agent, which acts as a consultant for design thinking and AI, incorporating AI into design thinking projects. And finally, we want to run a few workshops across our faculty to help the faculty as well as students understand about design thinking frameworks and AI use. From the research aspect of this, we're going to conduct a pre-post research study in another one of our units this semester without any of these resources that we talked about over here above. And then the semester after that, it'll be including those. And we're going to look at how, assessment outcomes might change from a student standpoint, from a teacher standpoint, as well as from an industry standpoint, because this particular unit we're looking at actually has industry connected to it. It's an industry project, basically. And just a few references, mainly for the design thinking aspect and for all the pictures that I've used here, which was based on ChatGPT Turbo, which I was playing around with. And acknowledgements to our main project team. Okay, so Ken, Rebecca, Masa, Shi, Young, Faham, and myself. So you can see from the Faculty of Engineering, a variety of schools across the Faculty of Engineering, and our external advisory team. So Sasha, thank you for helping us out at the start, because when we started off, I actually had little idea about actually how to go about doing this. We got some great advice from Sasha, from Mubasha, Danielu, Dimitri, Chuck, and Slaney. So academics and industry experts, nationally and internationally, it's been great working with them. And that's it. I'm happy to, I didn't have a question slide up, but happy to answer questions.
Excellent. Thank you, Hamish. One thing to note is that in our work, I didn't talk about project work, but we identified that project is one of the best opportunities for Gen AI integration. And the work that Hamish has just shown, it shows that potential. I have done a similar study myself, waiting publication, but it does show, again, the industry partners saw great satisfaction from the solutions that were coming from students when they were given full permission to use Gen AI. And they were following up on the students' thing. I just want to check, is Faham going to also talk about the other work, or are you stopping there, Hamish?
No, just quickly mention about that one. The cognitive that you have seen in here, University of Sydney, is just belongs to us. This is a particular platform of the ChatGPTs. Look like ChatGPTs belongs to the University of Sydney, and we are trying to engaging with the different subjects through to the canvas. This is just comments on. You can go ahead, Hamish, please.
Yeah, we're stopping there because that's the key part of the pilot, and everything else we're doing is basically an expansion of this in subsequent semesters, and including Faham's work.
Okay, so I just want to add there. So within the SIG, within the projects cluster, we've actually developed a framework for integrating Gen AI across the entire spectrum of project work, and that is something that's going to be integrated across 10 different subjects across 10 different universities going forward. Okay, let's now go back to Hamish, and any questions for Hamish on his work. Fantastic work.
I'd love to add that I'm looking forward to May's presentation as well, because I think one aspect of this is using AI to analyze data. That was one section which, although we did help students with it, I'm sure we could do, I could do a much better job at that. So looking forward to May's presentation there.
Helen, you have a question?
Yeah, I feel like I need to jump in there, particularly around the response that EA would require you to have a normal. Well, you didn't say it, but I assumed it was you were inferring a normal distribution in your marks. I'm not sure that's quite right, but that's okay. What I wanted to ask you was around that, and you found that you had to adjust the marking criteria because it was of such a greater quality. Which does that infer more efficient learning? And obviously, does that free up? Sorry, not obviously, but then does that free up the curriculum to consider other things? What's your view on that improved quality?
The efficiency of the learning, thanks, Helen. The efficiency of the learning was the reason we were able to get students to actually communicate with stakeholders directly rather than do online research, which can be done much faster. One of the most nerve-wracking elements of this for the students was because we didn't have industry people from industry already connected to this unit that we introduced them to. They actually literally needed to connect with them. The students needed to do it themselves, which in itself took a long time. I believe the quality improvement was mainly because they actually had to connect with these stakeholders, so they felt the problems more, and they felt like what they were creating or what they were coming up with was far more important than if they just did something online, because the report that they come up with, now they actually feel a much stronger connection with it. That would be my hypothesis. I'll know more from the reflection when we actually analyze that data.
So if I may, Sasha, have a follow-up on that?
Yeah.
So would it be true then that you would still get that higher quality if you took AI out of it? And if you did this before AI was around and you said to the students, go and make those connections yourself, would you get the same increase in quality, do you think?
It potentially, once again, I need to actually look at the data that's sent to us. Now, what's key here is I believe that yes, you can create a good quality assessment even without AI. However, rather than finishing in 9 weeks, it would have probably, to do the same thing, would have taken much longer. So of course you could, but my prediction would be there's no way we would be able to do the same thing without AI, because students will be spending much longer time on the gritty elements of this that AI could help them with, you know?
And I guess that comes back to the essence of my question, that greater efficiency in the learning, the quicker time frame that you're able to do it in. Does that then free up the curriculum to cover other aspects?
Yeah, it does, which is why, Helen, I was able to incorporate the communication with the stakeholders, because that in itself took about 4 weeks for them to reach out, to organize interviews and all that. And actually run the interviews, find time that these industry experts could actually do an interview, because they're all busy people.
Yeah. No, I get it now. Thank you. Thank you. I was a bit slow on the uptake, but now I understand what you're saying. That's terrific. Thank you.
Is there another question there for Hamish? Oh, excellent. Thank you very much, Hamish. Up next is data analysis with GenAI from Mei Lim from University of New South Wales.
Thanks, Sasha. I'm just going to share my screen. And thank you for putting me in this slot, because everyone else has done all the hard work and I just need to talk a little bit more and then we can have a nice discussion. There we go. And can you see my slide?
Yeah, but you're not in presentation mode.
Hang on. Oh, yes, that's right. Okay. And now I'm in presentation mode, yeah?
Yep.
Okay. All right. So my name is Mei Lim. I'm from the School of Chemical Engineering across the road from USYD, from the Uni of New South Wales. And in fact, I can see a lot of synergy between what they're doing at USYD and at UNSW. So I currently lead a wheel cluster at AAIEEC, and basically looking at GenAI as a tool to assess competency attainment. This project is underway very slowly, and I'll maybe quickly explain why. The moment you're starting to look at competency, you're basically starting to look at what students are doing and artifacts they're producing. And to use AI to look at that is not always quick, because there are privacy and cybersecurity consideration. Nonetheless, we done a bit of work, and I'm going to report a bit of the work I did last year, which will feed into what this cluster is doing. So I'm going to start by just showing 2 case studies. And the first case study is sense making inside the classroom. All right. So how do we use GenAI to go what's actually happening inside the classroom? And I'm actually standing, I'm not sure if you can see what's behind me, but I'm actually standing on the stage, UNSW graduation stage. And I remember graduating on this stage many, many, many years ago. And I was thinking back to 1994, and the way we teach back then is you go to a lecture, and then you do an assignment, and maybe you have an examination, and you got 30 contact hours a week, and you got 14 weeks of session. And in some ways, that way of teaching a bit like McDonald's. You got your lecture, you got your burger, you got your chips. And in 2024, with AI coming onto the scene, that changes a lot already. Because if you look at your assignment, you're never quite sure, did the student do it or did AI do it? And if you look at exams, you always that question of, how authentic it actually is exam and whether it's a valid assessment for engineering. So as Hamish has said before, the assessment strategy is shifting slowly more towards looking at the process of learning rather than the product of learning. At least that's how we're thinking about it currently. Not saying that this is definitely the solution to AI in education. Okay, so just a quick reintroduction. I'm a senior lecturer of engineering. I am not a data person or data insight person. And secondly, the use case here is in a particular course called Engineering Design and Professional Practice. And again, what Hamish has said, this sort of course really lends itself to the use of AI. And what I'm going to talk about is how we fight fire with fire. So how we use AI to help solve this issue of AI in education. Okay, so to give a bit of course context, this is again a design thinking course. And last year, the project we gave the student was on spent coffee grounds. So if you had just bought a cup of coffee this morning, something you should know is of all the coffee ground that went into making that coffee, only 10% end up in the cup. The rest of that end up in, the little bin that the barista sort of knocked the coffee maker thing over. And if you think about in Sydney itself, there's 921 cafes, each of them selling about 100 million cups of coffee every year. That's 3,000 tons of spent coffee ground per year being produced. And in 2019, 93% of that land end up in landfill, generating a lot of methane gas, and only 7% end up in horticulture. So we said to the student, could you, instead of putting that into landfill, turn that into something more useful? Now, if you give an engineering student a project like this, it will be solved within a day because they're going to go to Google and Google valorization of spent coffee ground, and Google will give them 1,000 possible answers, and they'll just pick the best one they like and they'll write it up. So what we did in this course is we say there's extra constraint. One of it was whatever technique they come up with has to make money for the cafe. So anyone who's been working in that sustainability area knows that the moment you try to make money and save the environment, it becomes a bit more tricky. And we can also say things like, and the coffee drinker has to love it, all right? So now there's triple constraint, and the student really need to think how to solve this problem. They just can't go to ChatGPT, type in a little prompt and get an answer there. And what we're starting to see is very critical is the student has some contact with industry. So I'm not sure if I can play this. So we took them to, this is the Sydney Convention Centre last year. There's a fine food convention there where the student gets to meet around 800 industry representative to talk about coffee. And you could see here, they have very interesting conversation. They ask all kind of questions, and I asked them to collect all the information on Padlet. So you could see this is just a student typing into their phone. I went to this fine food convention. I spoke to some industry, and they were saying something like, 800 to 900 grams of coffee will be generated per kilogram of coffee bean, so on and so forth. All right, lots of interesting stuff. Now, I am not able to read all these little input where there's like hundreds of them before the next lecture because we need to do some sense making. So the first thing I did was I took all that, I pulled that off Padlet, and here I'm just showing it on ChatGPT, but you can actually do it properly in using an API, and you analyze it and you get some nice summary. And then you take this to the classroom and you say, all right, this is what we saw last week. What do we all think? Okay, so for example here, sooner or later we're going to be able to see robots serving serving customers on table instead of a human. What does that mean? Okay, then we put the student into teams, and then we send them into our makerspace and say, all right, you need to actually come up with a physical solution. We're not that interested in report because anyone can write a report. How can you go into the makerspace and turn all that spent coffee ground into something useful? So in this case, here my student prototyping, turning spent coffee ground into spoons. And what we're starting to see here is in design thinking, the students meant to do user research, define the problem, come up with a solution, prototype, and do some testing. But what students tend to do is they tend to do it this way. They tend to come up with an idea, a solution actually, they prototype it, they test on the user, and then they realize the user actually hated the solution, and then they go, actually, what's the problem we're trying to solve? So because of that, we need to be able to monitor what the students are thinking, but without stepping in and doing the thinking for them. So the first place is to go where the student often go wrong when they are trying to solve problem. And what we saw was where they often go wrong is in meetings. So the first meeting, they come together, they talk to each other, they try to work out what the project brief is about, what the assessment is about, and then they start to make decisions. So what we did was we were able to capture the transcript from all this meeting, and then we push it through ChatGPT to analyze what the students are talking about and only pick up the things related to to the project. So we're not interested in what they're doing on the weekend. And it was able to do that. It was just putting out, things like a summary of the meeting, what action they have decided to take, what sort of follow-up, what kind of questions they have. This is really, really useful because you thought that I've explained to the student 100 times about what we're trying to do, and the same question pops up again and again. So what this means is I could then, if I see something is a bit strange, I could then go back to the teams, tap them on the shoulder and go, okay, you were saying that you were going to use the spent coffee ground to feed the dog. Are you sure that, coffee grounds are safe pet food? And then we can have a conversation about why it is or why it is not. The second thing that we then look at more towards the end of the project is around oral assessment. And you may have heard a few times people saying, oh, oral assessment is one of the solutions to academic integrity when it comes to AI, right? So in the old days, when we give oral assessment, you get a whole team, it goes to the front of the class, and some guy will give the introduction, some guy might talk about the methods, and some guy talks about the result, and maybe the one talks about the discussion and one talks about the conclusion. This is not really a good way for the student to learn how to present. So what we started to doing was we started to reorganize the student into pods, okay? So can you see that this is a typical classroom at UNSW? So these are the pods, pod 1, pod 2, pod 3. And what we do was we split the team up in such a way that each pod only contained one team member from each team. And this is how it actually looks like in real person. So you can see there's one group of students here with a member from each team on pod 5, and behind them is another pod with other group members. And what we're asking the students to do is give presentation, and this could be impromptu presentation after an exercise because that allows them a bit of sense making. And notice that there's a student filming because he's trying to collect what's actually going on in the classroom there. Again, we strip off that transcript. Oh, sorry, before I said that. And while the students are presenting, the other students are actually, I skipped ahead. So every student gets to present. So they all hear each other's presentation. And then this is the transcript. And notice that you do get a bit of banter in that transcript, but the AI can ignore that, all right? So it's just not looking at it from down here. And what we then do is, okay, based on the transcript, did the student do these following things that was in the rubric? Did they explain the problem? Did they consider the solution? And did the student produce any unique insight? What we saw was it was quite good at doing this sort of checkbox type evaluation. It sort of struggled a little bit more with the one down here. Did the student provide unique insight? Because AI is still at this stage last year, not very good at context-specific evaluation. But nonetheless, it was able to evaluate and it was able to write feedback for the student. So these are the feedback it gives to the student based on the various assessment criteria. At the same time the student's presenting, we ask the other team members to provide written feedback to the presenter. And this is done on Padlet. And again, we can grab all that information, put out some summary, and we can also look at what the students are writing, and then we can then give it back to the presenter so that they could also make sense about what actually is going on in your presentation. What we saw in that particular use case was the feedback from the AI is quite detailed. There's a lot of information there. Whereas the feedback from students varies. It can be very brief like this, like, hey, good job. And it can be quite detailed, like this slide here, where it's a lot of information. In fact, in some way, more detailed, more contextualized than the AI's feedback. But what we really saw was more work really need to be done on feedback literacy. Our students are not very good at doing that. Like, they're not very good at evaluating why something is good or something is bad. They kind of just say, yeah, it's good, yeah, it's bad. But work needs to be done there. Okay, so one quick thing here, I'm just checking the time to make sure I don't go over time. Another issue with course, if I show you a course, the traditional 1994 courses, the McDonald's courses, and this sort of project courses, which are a bit more like, Korean barbecue. You go to Korean barbecue, there's a buffet, and then you have to cook it yourself. And when we ask the student which one do they like, if you just use student survey, they tend to say, hey, we like this sort of traditional courses, and this sort of Korean barbecue courses get a little bit of thumb down. And the reason for that is because it's a course with a lot of moving parts, and many things can go wrong. And for us to actually understand what's actually going on in the students' course is also quite tricky. So this is sort of the comments that my student will give me after a course like Desert 2000. And if you look at what they're happy with and what they're unhappy with is often twice as long as what they are happy with. And this is just for 95 students. So at UNSW, we got courses with 400, 500 students. So there's a lot of information to process there. So again, we can use GenAI put through the process, and we started to see a bit of patterns around what students want. One thing we could definitely see is they want more formative assessment, more opportunity for feedback, more opportunity for second chances, and peer assessment. So weirdly, they actually do like peer assessment because it allows them to see what each others are doing. I think I got 5 more minutes. Sasha?
Yep.
All right, so I'll just do this last bit. So before we're talking about GenAI used inside the classroom, and I just want to give a little simple use case outside the classroom. So this is a little proof of concept we did early in the year. It's a very small proof of concept with only a very short number, with only a small number of report, but it was telling us something quite interesting about GenAI, about what students are doing when they are doing industrial training. So for those of you who are not engineering educators, industrial training is just a placement most EA accredited engineering degree has to implement. And what that means is the student has to go out, find an engineering role and do it for about 60 days at least. So at UNSW, when the student has finished their placement, they come back and they write a report for us, and we call this the IT report. This way of doing things is really old-fashioned. It's from 2017, but because we got data from all our engineering schools, so at UNSW, industry placement is managed at the faculty level. So we got the same report from ed school, and we thought, wonder what's in there, because we don't all mark the report together. We mark our report separately within our school. So. And the way we mark the report is we want to see if the students have met the stage 1 competency when they were out there in placement. So these are typically 4th-year students. And then let me just remind you again, the stage 1 competency consists of 3 tables. The first one is knowledge and skill based. So this is the sort of the more fundamental engineering, maths, physics, chemistry type of knowledge that the student needs to add. And then table 2 is more the engineering skill set. So things like project management, complex system thinking, solving complex engineering problem. And table 3 is sort of professional and personal attributes. And for the report, we asked them to look at 1 and 2 and not 3, because 3, using that system, we actually asked the placement provider to evaluate the students, only 1 and 2. And this is typically what the student would write. So they would say something like, all right, I have met indicator attainment 1.3A, proficiency applying advanced technical knowledge and skill in at least one specialized practice, blah, blah, blah. And then they'll write the evidence of how they think they have met this competency. And this is kind of what we saw when the GenAI's output. We find that the AI, at least for that small sample set, was able to say yes or no whether the student met the criteria, and also output the what I call description of how they met that indicator. The other thing we noticed was, and this is actually a bit more interesting, if you go back to that sample I gave you, so notice that the student has indicated that she has met 1.3A, and that's the fundamental skills and knowledge. But if you actually read what she did, she was designing bridges, and she was designing bridges in quite high level way, I think. I'm not a civil engineer, I'm a chemical engineer. But when I read through that, I go, well, this is pretty cool. Like, you're building bridges, you're doing modeling, you're trying to do a bit of risk assessment, sizing, etc., etc. So why did you say you're only, meeting 1.3? And if you go back to the table, 1.3 is just proficiently apply advanced technical knowledge and skill in at least one domain. But what she wrote looks more like 2.2, where she's using computer models, she's doing design, she's doing analysis, she's doing safety testing, blah, blah, blah. So why is my student say she's doing like a first year popsicle stick bridges, when in fact she's building something that looks more like the Sydney Harbour Bridge? And this says to me, perhaps our students are not really thinking of themselves as engineers as we like, or perhaps we have not really inculcate what actually being an engineer actually mean to our student. And when it comes to that kind of thinking, perhaps we need to provide more feedback to the student. Everything you do at uni, what is that actually is when it comes to competency. And when you go and do something, what does it mean again? So this is sort of the thing we're thinking about in Wheel Cluster Project 1. And I'm going to stop there because I felt like I've been talking for a long time, and I'm happy to take questions.
Excellent. Thank you, Maya. I found that very fascinating. Are there any questions? Helen?
Yeah, it's terrific work, May, and really keen to explore that work with the EA competencies, of course. But it struck me that it demonstrates perhaps a bit of a flaw in the competencies themselves that we need to address in how they're interpreted. And I don't think I've ever seen research before where the specific interpretation of them has been demonstrated. So yeah, really keen to talk to you about how we can look at that. Sorry,
Thanks.
I didn't.
Thanks, Helen. Yeah, I think table one is where we found it very, very tricky because the description in table one for the items are very, very brief, and they might actually be discipline specific. And what would be interesting to see is if you could get reports from different university, even just to compare notes, just to go, what are our students writing when they're out there? And the second thing is the AI can also pull out where the students are doing their placement. So for the first time, we can actually know where they're going. Whereas before, it was kind of in this big CRM that, nobody ever had real time to look at. But if we could start looking into where they're going, what they're doing, what did they learn? Are they really doing this first year levels, low level stuff, or they're not given the right opportunity, or they just not realize that they've been given opportunity, but they didn't see it.
Yeah, no, it's very insightful.
Kathy, one quick one.
Yeah, sorry. I mean, the other thing I wonder about is, are the students sort of landing on the first thing that might look somewhat similar to what they're doing, so they don't, they're time poor, or they believe they're time poor. I'm not doubting that for a second, but they believe that they're time poor, so therefore it's like, oh, that looks kind of sort of like I could shoehorn something in there and get it done. So I wonder if maybe that's part of the process. Are you planning on interviewing some students as well, or just?
Yes, we're thinking of whether we could look at more data set to make sure that this is definitely the case, and it's not just my 20 students who are just writing like this. I think it's because it's like if you look through the table, it's the first thing you're going to see. It's things that they're very familiar with at uni. So when they write reflection, it will be things like, oh yeah, I did this math equation to this, projects. Whereas we never really say to them, right now you're doing, project management. Right now you're doing complex engineering. Right now you're doing system engineering. We very rarely say that to them. But in fact, at uni, they do that too. In fact, they do a lot of project management at uni. So we just maybe need to make that a bit more explicit. So one thing we thought of looking into is as the student write, maybe the AI start asking them, right? Like the AI can read what they write and then go, oh, could you elaborate a bit more on that? What does that actually mean when you say that you're using this CAD software? Just a bit more sense making so that they could then see that the engineering identity, which I think is important. Now, we don't all wear lab coat, right? We wear leather jackets and stuff. So
fascinating. I look forward to reading more. Thank you.
Thank you.
Karen, last one.
I just wanted to chime in and say, I wonder if the complexity as well is that in engineering practice, you don't do one competency at a time. No one does.
No.
We're all exercising all of those competencies together in a single episode in practice. And
Yes.
I don't think we necessarily spend enough time talking to our students about that.
Yes.
I often say to students, it's not like you put on your engineer hat, then you take it off and you put on your teamwork hat.
Yes.
You're engineering within a team. It's all part of the same practice. So, I think that would be really interesting to do some kind of cognitive interviewing of students to understand what sense they make of that list. I think it'd be worthwhile doing with academics as well, because I think many of us similarly kind of struggle with how to take that competency list, which breaks it down nicely, but actually put it beside an example of embodied practice, which cuts on all of them. Anyway.
Exactly. Yeah. No, very, very right. Yeah. I mean, I started questioning it myself. I started to go, what does this actually mean when we say that the student is, yeah.
Excellent. Thank you very much, May. That was a great presentation. Next, we have Shannon Reyes from the University of Melbourne talking about peer review of student codes.
All right. Hi, everyone. Let me just share my screen. I can work the buttons. Oh, that's the wrong side of it. We'll get there. Okay. Hi, everyone. My name's Shannon. I'm a lecturer with the Teaching and Learning Lab in the Faculty of Engineering and IT at the University of Melbourne. I'm an electrical engineer as my background, and today I'm going to be talking about some work that we've done in GenAI feedback. The example that we have is in code review in a programming subject, but I did want to, I guess, embed that more broadly in just the idea of how we can use GenAI to give feedback to students. I will quickly, because Sasha asked to, there we go, mention the AAIEEC. I really struggle to say that every time. Programming cluster. I'm leading a project within this looking at expanding the work that we've done already on GenAI code review with a few other people from other universities around how we can embed that. But also the programming cluster is interested in essentially how we teach programming currently to especially first year students, and how that may or may not need to change given AI. In other words, what is the foundational skills we need to teach students around coding or programming, such that they can use generative AI as a power amplifier for them, which, as I know I can, as someone who's learnt a lot about coding. But if we gave AI to the students without any knowledge of coding, it obviously won't be as beneficial to them. So what do we need to teach them before we give them access to the AI, or how does that work? It's one of the big questions that we're looking or interested in answering, but we don't have a project on at the moment. So as I mentioned, I'm going to talk about an example of how we've embedded GenAI with feedback, but I want to talk about it more broadly in the context of how we integrate GenAI feedback into our subject. And this is feedback for students. I think this ties on really nicely from what May was just talking about, which is kind of using, from what I understood of it, using GenAI to look at the student's work and their reflections and inform the assessment and the teacher of the student. Now this is giving that feedback directly to the students. So when we talk about GenAI feedback, I think it's really important to talk about how that feedback is perceived, or in other words, the source of that feedback. And the way that I've kind of categorized that, or we in our small group have categorized that, is it authoritative feedback, typically from a teacher or some other source of authority? Doesn't have to be a teacher. Is it fallible feedback? That's feedback from often a peer or a near peer, or any sort of feedback that the student deems as being untrustworthy. Or is it self-feedback, which kind of just to pick another word to go along with this, developmental feedback, feedback that they can use for reflection. And we are not in full control over, I guess, how the student makes these perceptions. It is really embedded in their culture, their upbringing, where they've come from, what news articles they follow, what news they read and subscribe to, and what trust and faith they put into those articles as well. So we see a big spectrum of how students position feedback, and in particular position GenAI feedback as well. So when we talk about GenAI authoritative feedback, that is GenAI feedback that we have as the academics, as the course coordinators, subject coordinators, whatever, have assigned authority to the students. Some notes around this for when using GenAI authoritative feedback. I think different universities will have different policies on this, but certainly our position, or my position on this, is that it should always be human in the loop. We shouldn't be fully trusting the AI, I guess is what I'm saying at this point. We know it can make mistakes or hallucinate. Sasha talked about a bunch of areas already where it was unable to perform this, that, or the other. So we need to have that human in the loop aspect to it if we're going to have any sort of authoritatively given feedback from the GenAI. We've found in our experiments this typically works better on small and bespoke criteria, which doesn't mean you can only use it for small and bespoke things, but it's better to have it look at, if you have a large complex thing, say a report, for example, have it look at small aspects of the report and then combine all that together, rather than trying to just get it to critique one large report with a simple prompt in one go. And typically the reliability for the perception of the users, for everyone's, I guess, comfortability of it, comfortableness with using the tool, it generally has to be perceived to be as good, if not better, than how students actually perform. A colleague of mine, Dr. Chris Honig, has done some early work on investigating how its use as a marker, as an AI marker, and certainly found that it can perform just as good as his human markers. However, that's kind of not good enough. The analogy he gives is if we have the robot cars, autonomous driving, it needs to be performing almost an order of magnitude better than what human driving is before people will feel comfortable or safe getting in that car. They don't want an autonomous car to be as good as a human driver. They want it to be that much better. And the same goes with the AI giving feedback. We're not okay with it giving just an okay result. I don't have an example for authoritative feedback. That's not a space that I'm really working in. I think there's a lot of issues with giving the AI that authority at this point in time. In terms of GenAI fallible feedback, so this is the peer or near peer feedback. This is the space that I've more been working in. And then here it's really down to the student perception or the work that we can do to try and establish that student perception before they get that feedback. So making it clear to the students through AI literacy training or AI ethics training or preparation activities with the students that what you're going to get out of the AI, it is not a source of truth. It's something that you should be critically analyzing, reflecting on, and interrogating as well. So in this case, first off, when the students must perceive the AI as fallible for this to be working. If they're not perceiving it, and if whatever reason due to the structure of the activity or the student's own personal beliefs or whatever, they're assigning more authority to it than not, then that's a problem that you need to be solving in this regard. The way this is handled, as I mentioned, need to be teaching AI literacy alongside these activities to make it clear how the students should be viewing that AI. These could be simple activities such as where students get it to interact with AI, get it to produce something, and then they can interrogate the validity of what it's produced, find the mistakes, the AI sort of activities that you might have been aware of. And we found this use case is best suited for formative feedback situations, ideally prior to an assessment being submitted rather than post an assessment being submitted. So now I'll get into the example that I guess is the impetus for this discussion here. So there was a subject called software project, very inventive name, Comp 90082. It's really important to note at this point that Dr. Eduardo Oliveira is the subject coordinator, and he's the one who initiated this project and is the leader, I guess, of this research project. I'm just a member of it. And this was his project to begin with. So in this subject, it's a long-term project-based subject where students work with industry partners to develop software engineering solutions, coding solutions. This is a very advanced subject. Students are meant to be applying skills and knowledges that they've already learned. It's not about teaching them the fundamentals of programming. In that, they're working with industry code. And part of the way this subject has run in the past is that students would be asked to undertake a peer code review, which is the standard industry practice for checking code for security defects, other issues, structural defects, etc. What we decided to do was to implement a two-phase approach where we gave students the option of picking either the AI review or the human review, and then having another option to do the other review at a later point in the semester. We were positioned it alongside the peer review so as to create that sense that this is a fallible review. This should be considered the same way that you would consider a review from one of your student peers, specifically positioning it not as an authoritative review. The way that we prompted the AI was to use what you're seeing on the screen now is the prompt itself, which came from a bit of research that said this is how we should be evaluating code, a checklist essentially, which is what figure A is. Figure B is that checklist converted into a prompt, and then the unlabeled figure C has a typical response on one of the pieces of the student's codes that you might be able to have a look at there. And so this process here mirrored what the student peer review done as well. They were given a spreadsheet with these same criteria in it that they were meant to fill out and complete, and fields for various inputs on them. We gave this to the students They accessed it through their normal coding platform, so it was seamless. It didn't add extra steps to the workload, and had a look at how they went. So in terms of its performance on identifying defects, the blue in these diagrams and graphs is the GenAI review. It, simply put, it massively outperformed the student peer review and in the total number of issues identified on average. It underperformed on a couple of the specific types of issues, but in generally speaking, it outperformed on most of them. So massively outperformed in visual representation, documentation, and then underperformed on structure and logic compared to the human review or the peer review. And then and was significantly better at identifying trivial issues compared to the more complex issues, but still was comparable for the other issues as well. So in other words, it's performed a lot better at identifying simple issues and a lot more issues than the other students, but in general performed as good as the peers in terms of identifying issues, giving issues in the code. Actually, I'll talk about another example before I talk about some of these findings from this result. This is published at ASCII last year, so you can go look up the paper. I can share that with you if you want it later. Another subject that we implemented this in, we're still analyzing this data yet, but it ran last semester. This subject is in electrical engineering. It's called AI for robotics. Students make a robot with AI, and they write some reports about that. So in this instance, it's not code review we're doing now, but this is a review or feedback on a preliminary report before they submit the report. And there were specific criteria that the academic of the subject was interested in improving in the students that they had repeatedly found students struggling with and not reporting on appropriately. So we went through an iterative process to develop the prompt that we see here. I don't expect you to read it. It's quite complex, but it touches on some of those same points in which it is picking out individual bespoke things for the AI to reflect and comment on. I will say at this point, the challenge we found here was getting it to be critical and getting it to give constructive and useful feedback rather than just be overly nice and surface level. So the prompting took a bit of work to get to this point. So we ran this, the prompt was working well, and as I said, we're still analyzing the results. But in terms of both of these projects, I'm not sure if there's another page. Yeah, so in terms of both of these projects, what we really found, I guess one thing that wasn't overly surprising to me at least, but certainly worthy of noting, is that probably like most learning activities, there was certainly a student preference factor, and there were some students that did not like the GenAI code review or did not like the GenAI review, would have preferred to have that review with a real person or a human. And they had that opportunity. So we weren't limiting their choice to do that. By and large, the majority of students preferred the GenAI review, and we had significantly higher engagement with these processes than we have had in the past. Pardon me. It's not clear whether the reasons they don't like it is because of their own biases and beliefs, or whether it didn't perform well for them at this point. But ultimately, there is certainly a personal preference aspect to this thing. What we did find that we think is really important and really interesting is that regardless of whether the student liked it or didn't like it or the performance of it, what these activities did was got the students spending more time in their material, more time in their work, more time developing, writing, critiquing, evaluating what they've done. So essentially these activities, these AI generated reviews, got the students to go back and look at their work and think about it, and either like realized, oh yeah, I did make all these mistakes, I'm going to go fix them now, here's how I'm going to fix it. Or no, the AI is completely wrong, I don't believe it, it's terrible, this was a waste of my time. But they've spent the time going back and looking at their work so that they could prove that the AI had made some mistake, or that its advice was not really that relevant to them or not useful to them. And that was really interesting finding that we had from this. I'm not sure of the time because the screen is blocking.
Yeah, good time for questions.
I just got one quick more thing I'll touch on, and then we'll finish. Sorry. And so the last one I just want to talk about was the AI developmental feedback. So this is the self-feedback. So to put simply, this is self-reflection on students' learning. And this is another area that kind of overlaps a little bit with the fallible feedback. but it's something that one of the dot points here I've got here must be used cautiously. So it's hard to implement without it becoming fallible feedback or authoritative feedback. But it also will occur naturally when students want to reflect on their own learning. They will naturally go to, especially as they become more familiar with the AI tools, as the new generation comes through, they'll go to the generative AI, ChatGPT, whatever, and use that as a tool to solidify their learning, to solidify their understanding. They attended a lecture, they read some notes, they didn't understand something, they're going to go to that and discuss and talk with it. In terms of how you might structurally put this in, we're looking at a project at the moment where we're going to be providing essentially an example prompt and a process to students to follow that they can use with the AI to reflect on the work that they've done in a project-based ideation sort of activity that we have the students doing. The purpose of this approach is to have the students seek their own understanding on both the content and their position or their beliefs in relation to the content, the material that we're looking at. So that is it. That's the last one I'll talk about. Questions?
Anybody? Here we go. Mubasha.
Hi, Shannon. Thanks a lot for the talk. I just have a question that which year students, like which year of the education these students are taking? Like, is it in their first year or third year?
Yeah. So I'm from University of Melbourne, so we have what's called the Melbourne model. So our students do 3 years undergrad and then 2-year or 1-year masters, depending on where they're coming from and what they're doing. All those subjects are master's level subjects that we're talking about. The software project is final year masters, but the other project, I believe, it can be taken in the beginning of masters. So it could be a student who's come in from overseas, for example, with whatever degree they have, and it might be one of the first subjects that they're doing in their degree. But both of the subjects are meant to be they're applying stuff they've already learned. So certainly not first or second year equivalent. It'd be more like third or fourth year equivalent to a traditional 4-year degree.
Okay. Yeah. And what is the size of the code they are looking into? Like, how long is the code?
The cohort, was that, sorry?
No, code. Like
the code.
If they are looking for the feedback, how long is the code?
Yes, yeah, good question. So with the codes, the projects that the students are working on are from industry basically. And so sometimes it's fairly bespoke and contained, and sometimes they're absolutely enormous and ridiculous. And that was certainly some of the issues that students had with the feedback was when it didn't have the full context of the system that the code was working in, they found it to be less useful. We've got some recent work that we've been doing and some changes to the mechanics of how the feedback is generated, how the AI is prompted, using things like retrieval augmented generation and a couple other tricks to give it that expanded context. And so we're going to see how that's improved. We've got some papers coming out in ASCLA at the end of this year to see how that improves its ability to handle really, really large code sets, or just to give it more contextual information that the students might type into the AI. But yeah, we certainly found that an issue where the codes were really large. I can't tell you exactly in terms of like pages or lines or anything, but when it was very large, it wasn't able to, or it would make mistakes basically because it didn't know where this code sat. This was one file of 6 files. But we certainly would send a single file at a time to the AI to get review on, but not multiple files, if that helps answer your question.
Thanks.
No worries.
Is there any other questions for Shannon? If not, we actually move on to Mubasha for our final presentation. Unbelievably, we are completely on time. Well done, all the presenters.
Okay, I will share. Can you see my screen?
It's coming now.
Oh, is it good? Okay, can you see the screen?
Yeah.
Okay, thank you. So my name is Mubashir. I'm in University of Western Australia. So for me, it's pretty much early in the morning, sunny. That's good. And I'm working in computer science and software engineering. So today, I will be talking about just how to create or what are the guidelines for creating a GenAI proof assessments. That's a bit tricky, but it has some experience in it. So, come on, start working. Wait. Okay. So this is just actually, Shannon has already covered it, that we have a programming cluster. These are the 7 members: Shannon, me, Derek, Ari, Jeff, Sasha, and Rez. If you want to join it, please feel free to join. There are 4 different projects which we have shortlisted. GenAI peer code review, where Shannon has already shown you perception of GenAI versus reality. GenAI for engagement and GenAI for learning outcomes. Now, coding assessment integrity. So we had a comprehensive study where different, I think so, we have 8 to 10 different engineerings where we have actually looked into the assessments and integrity. Now, my part was that actually I was part of the study. I had a computer science background, AI expertise in research also. So I had to look into the coding assessments integrity. So now, just before going into it, just let me give you a little bit of the you can say a history of it. This is the unit. This is the first basic unit for every programmer, every computer science student, or software engineering, or data science, or anyone who is going to take programming seriously in their future. So we have actually 3 different units. One is this unit where we are looking for all the students who are actually very serious. Their career will involve a lot of programming. It is either from engineering or computer science, data science, anywhere. The second unit is basically for engineers only, where those engineers who just want to apply some of the programming concepts. They do not want to dig deeper into it. And the third one is all those who do not have any mathematical background and they just want to learn that can they use it. So we have got 3. So we are actually being very careful about this unit because one of the things is that enrollment has increased from 200 per or 250 per semester to 750. And we are pretty much having 1,500 or to 1,600 students per year in this. So we want this unit to be first obstacle that they can decide about their future, because we do not have a long tail of programmers who cannot program well in the high-level process. So this is the first unit they have to take in any of the programs. Now, it is actually developed like these assessments. There are 3 different types of assessments. Final exam, which is completely invigilated, closed block course notes, and they have to write the code because we cannot have so many computers at one place to entertain all of them. It has a 55% weightage. Then we have a couple of projects. Comprisingly, they are 35% of the final grade. These projects are obviously, project 1 is very simple, while project 2 is a little bit much more complex. Then we have got the weekly labs. Weekly labs are basically, we have 5 labs which they have to do. And each lab is actually, all the labs combined together will be 10%. And each lab will have approximately 20 to 25 small questions. But these questions are very, very small, like they are looking for just 5 lines of code or 6 lines of code. Project 1 and 2 are really comprehensive programming. Final exam has the wide range of the questions, like 7 to 8 questions, ranging the difficulty. The marks are allocated like 5 to maximum of 20. So this is what has happening was actually over like 2016, we started working over this unit, and 2020, the COVID hit, we came up. And when after the COVID years, we came to the conclusion that these are the assessments which are really working well and we should use them. Now, interestingly, ChatGPT came in, and Sasha and we actually got together and we said, okay, let's see if students or ChatGPT actually attempts our assessments. So in the recent study, which will be, I hope, which will be soon live, and I think Sasha will be able to share the links and details. what happened is that overall, if you look at the picture, we have the weekly labs, so students just have to copy paste the codes into or questions into the GenAI, any of the GenAI tools, and they can easily pass all the labs. Now remember, it is only 10%. So, but if you can see that actually ChatGPT-4 is giving 94% marks over all the questions. Some of the questions which were wrong, to be honest, most of them were actually MCQs style questions where there were actually 2 answers which were very close, and GenAI just mixed it up. Project 1, obviously, it is a simple project where from the programming perspective, we are looking at the simple loops. And actually, one of the tricks which we were doing is that, and now we are actually utilizing on it, is that we are using CSV files. So CSV files have the data which students have to import and then actually play with it. Obviously, one of the things which we are doing in the projects is that we are providing them a sample file and their sample results. So remember, project 1 is, or project 2 is basically 6 pages document which they have to read through, understand the guidelines, and there are requirements which are mentioned. Sample provided is actually just a sample. No marks will be given if your code works with the sample only. There will be a testing file which will be far more different. So we are looking for the generalizability of the solution also. I will be looking into it, and I'll be sharing which type of marking rubrics I have used so that actually it can give you a guideline. Then the final exam is obviously 55%. So if you look into it, final exam, obviously it's 2 hours, closed book, closed notes. So the difficulty level is very low, just to make sure that actually students can attempt it. And or if GenAI is allowed there, so they can score 100% marks. And interestingly, over the last 6 years, we can see actually that online exams were twice happened, and only that was the only time when someone was able to score 100% marks in the exam. Otherwise, nobody was able to do it. So obviously, we cannot think about it that we can go to the final exam, online final exam under these circumstances. Project 1, the best marks were 1/3, which was still not passing. And project 2 was straight away 0 because it is really complex and it needs a lot of understanding of the data. You have to analyze it. And then there are images involved in it so that actually they have to understand the images and use their critical thinking to actually look into it, what is required. So this is the detail of it. If it will be there in the paper, which you can look into it. I just want to mention that actually all of them, if you look into it, that actually projects, if you look, we have tried to do some prompt engineering, and Sasha is also the one who also tried it. And interestingly, in some cases it worked, some cases. So, but projects, we did all our efforts to actually Now, one of the problem is that if we are doing prompt engineering, students or us, we need to know what is the correct solution. And this is what was happening, that actually if students do not know what the correct solution will look like, they will accept whatever is provided, and that can be really detrimental to their learning. So some of the weaknesses is that anything which is simple and is straightforward, like you can see, this is an example of bubble sort of algorithm in Python. Straight away, it will provide you the code. Yes, the good thing is that it will explain it, but it will always facilitate you that you can just copy paste it and it will be given. Now, all our actually labs are basically simple Moodle quizzes where the students are provided a text box where they paste their code, and it has some few 4 to 5 random checks, and it will just give them the marks if it is correct or not. So it is automatically graded. We don't have to grade it. I forgot to mention it at projects. In projects, what happened is that we manually grade it because we have tried over the time this Moodle system. The problem is that students actually somehow get out of it, and they actually do not do the assessment. Also, they never liked from the feedback that they never like the feedback which they get of the grading. They want to have a more description and they want to have more details of it, that where they went wrong. Also, one of the limitations of these type of Moodle assessments is basically it is looking for the specific answers and it cannot partial grading. So in projects, it's a big weightage. We want to have the partial grading. So coming back to some of the weaknesses of our existing assessments, If it is very straightforward or simple to do, ChatGPT gives you straightforward a very good answer. You do not need to know a correct answer to actually find it out, is it correct or not. You can just copy paste it and it will work for you. If it can help students on the new projects. Now that is actually something which we have to look into it, that how we can overcome this issue, because if it is providing them a hands-on onto the project, which means that it is covering the problem decomposition skills, which is part of the computational thinking skills. So they get actually a good start from there. These are the weaknesses. How we can play with them, that actually we can use them like simple assessments for the engagement, to increase the engagement. We do not give them the high marks, but they can have a practice on it. Yes, there will be a cohort which will be actually not using it properly. They may be actually just copy pasting without learning, but you do not, but your main purpose is to increase the engagement for majority of the students. So it is just like the same attendances, like in US, there, like it was very common. We used to go to the lecture and there will be a pop quiz, and the pop quiz was just write your name and the student ID. That's all, nothing else. Okay. Now, one of the things is the projects is that when we brought up the projects, it went and it ended at the end, it mentioned, make sure to test this script with the provided CSV file and adjust as needed for any edge cases or specific requirements. So that was something where actually I'm focusing, and I make sure that actually they are provided a testing file, which is far much different than the sample file which is provided to them. Some of these trends. Now, one of the things I'm trying to actually pursue and actually educate others, that there's a difference between the coding and the computational thinking skills. Computational thinking skills involves problem decomposition, abstraction, pattern recognition, and then the last one is algorithm. Coding is no more part of it. While on the other hand, coding is basically when you are typing the code and you are actually, so it's the transformation of the algorithm to the coders. In the earlier practices of the computer science industry, if you read the history, you will realize that there were coders whose job was that they will be provided the algorithm and they just have to code. Some of the other strengths which we can have is that analysis of data. So if we can actually give them the CSV file or data which needs to be analyzed. Now, what we analyze is that understanding the data, how you can manipulate it. Is there any actually error in the data, or what happens if there are any errors in the data? Because it's unforeseen, like age. One of the factors which we can do is that I provided the age of the participants of the data, and then actually one of the element has got age is equal to negative, which is impossible, like it cannot happen. Interaction with images and other files. That is one of the very, very biggest strength, and that's where the projects in my unit actually lies. What I do is that I put up a couple of images, and these images need to be understood. Yes, the ChatGPT, DALL-E, and all those tools, they can understand it, but the problem is that actually it is still difficult for them to pinpoint what are the things inside it. Like I have tried many times that I will put a smiling face there on the ChatGPT, and I'll say, okay, can you pinpoint or segment the part from where you can actually get the expression that the person is smiling? And it says that it is unable to do it. So still, this is something which we can use. I use some of the, like one of the assessments, what I did is that I provided them the face and I said, okay, can you see there are landmarks on the faces and can you find the distance between them? So obviously ChatGPT couldn't understand these things. Lastly, generalized solutions. This is very, very important. If we are looking for the generalized solution, not specific, so obviously the grading will be a part where we cannot have, probably we will not be able to have automated grading, but that can actually help us a lot. So testing files are far different than the sample files if we use it. These are the extracts from the ACS guidelines. So what I'm doing is that I'm sharing these guidelines to the students in the project sheet. And these actually explicitly, if you look into it, they explicitly states that involves wide range and conflicting technical computing and other issues. Has no obvious solution, requires conceptual thinking and innovative analysis. Analytical approach, infrequent encountered issues like what are the errors or corner cases which you can think of, outside problems, many component and subparts which creates problem decomposition, ill-defined and unknown problems, because the real-world problems are normally ill-defined or unknown. Now, this, if you look into it, these are all technically comes under the umbrella of the computational thinking skills. And that what actually my focus is nowadays into the programming, that this is the first unit students need to develop for computational thinking skills. Okay, I'm left with 5 more minutes. Okay, sample marking guide. This is the marking guide which so I am using a testing file which is much more different, like it is altogether different from the sample file which is provided to them. If you look at the first 4, these are the just normal outcomes which I'm looking for, like what will be the outcome 1, 2, 3, and 4. And obviously there are multiple testing files across which it will be checked. But if you look after that these will contain only 8 and 60 and 14 marks out of 30. But if you look at rest of the marks, especially these cases are something which they have to think by themselves. Like what happens if the columns are reordered? What happens? There are some unique IDs. What happens if the unique IDs, there are repeated IDs? So what should they do with this data? What happened to the case insensitivity, like capital and lowercase? Also, divide by 0 error. What happened that actually they are asked to actually calculate, find some things like standard deviation, and somehow it gives divide by 0 error. What happens if the file does not exist? It can happen. Or file does not have any data. Or file has got just a header and nothing under it. So these are some of the things. Also, what happens, there is an invalid data, like actually date is expected and rather than date, we have got actually as just a number or some other thing. Or ID is expected to be alphanumeric and we realize that actually it has a special characters. What will happen to those? These are the things which became a little bit different and students have to think slightly out of their normal pattern. And actually, interestingly, GenAI can still not overcome this thing. Now, this is actually, again, from the same study. We have got the programming. What are the impacts of it? So short term, yes, external files are working well. If you have an external files, probably ChatGPT will not be able to give you the correct answer. Even if it states that it is actually giving a correct answer, it doesn't work normally most of the time. So we have a good solution that we can use those extra files. But the problem is that long term, it is improving. As an AI specialist, yep, it will be solved soon that those images and all those things, they will be understood by the GenAI. GenAI will be able to solve the problem. The point is that can we shift our focus from the coding to computational thinking? That will be the thing which will be left. In my actually understanding and I think I can, over the last 3-4 years, when I'm teaching this unit and I'm actually looking at the new students, coding will be replaced in the next decade. Like it will be easy. You can actually mention it, any of the GenAI tools, and they will actually code it for you. The thing which will be left will be actually computational thinking. Now, what will happen in the computational thinking? Can they have a big problem? They can split into different small tasks. Then can we recognize the pattern and use it? Also, the code provided by the GenAI, can they actually thoroughly debug it? That is one of the very, very important aspects in the industry. Also, what about the legacy issues? If there's a code available which is working, how you wrap it around and actually develop your own code on top of it. But students need to know what is coding before they can actually do these things. And for that purpose, we need to still teach them how to do coding and to understand what is the correct output. So computational thinking will be very, very important. Some of the things for the assessments, like what should be the assessments? Yes, we can have a simple programming assessments, but have a very low value of the marks, and it is normally used for the student engagement and learning. One of the good things about the GenAI is that it explains you the code also, so students can learn from there. It is just to actually have the engagement and learning. Complex programming assessments, create them using the images and data files. Still, I'm trying to find a solution for actually hired programmers who can actually solve your assessments. There is no solution for that, to be honest, right now with me. But the point is that actually, if you use images and data files, at least GenAI will not be able to solve it with the Obviously, you have to create a good marking rubric around it so that actually it is not tested with the sample files which are provided. Testing files should be simple, different than the sample files. Make students aware of some examples of benefits and pitfalls. Now, one of the major also study which I have mentioned in the program is the perception versus the reality. Students have started perceiving that actually everything which GenAI is giving is correct, which is not the case. And the students, many of the time, what happens is that students actually believe that it is correct, and then actually they don't realize that that's not the best solution. So we need to have the GenAI workshops to solve the complex problems. I will encourage, I am trying to embed it in my unit also, that I will use the GenAI to solve one of the projects. And I will tell them, look, these are the problems which are having. So GenAI is not always reliable. Improve computational thinking and code debugging skills. This is something which will be required in the future. I don't think so that writing from the scratch codes will be something which will be required in the future, but the students need to understand how do they work. Focus on computational thinking as a transferable skills to program in different languages. This is one of the things which is going to be very, very popular. We will be just learning one of the programming language to understand the computational thinking or learn or develop those skills. And I believe that actually it will be so easy that any programming language can be used. And each programmer can use any of the programming languages. We don't have to learn all those different programming languages in future. Final exams. Yes, we have to go for invigilated final exams. Either you do it on computers or paper-based. It should be actually, we cannot allow GenAI to understand their book-to learning. Otherwise, it is very, very difficult to ensure that actually what has happened and have they learned anything, especially for the first year units. Yes, for the higher level units, it is possible that actually you can have those type of take-home assessments and all those things. For this case, for first year, where we need to know that how much they have learned, invigilated final exams are my recommendations. Computational thinking, last line, which I would like you to take it, computational thinking skills will be highly required, but not coding in future. And yes, our study will be soon out. This is the actually QR code where it is expected to be uploaded. It will be Australasian Journal of Engineering Education. And then if you want to join our cluster, feel free to join on this link. And we normally have once a month or once in 2 months, we have a meeting and we can look into it, the projects differently we are doing. You can be part of them. And thank you very much. I hope I'm on time. Yep.
Thank you, Mbasha. Very well. Before we go into questions from Mbasha, I just want to thank all the presenters today. They've done a fantastic job. They've given you very different insights into the risks and benefits and opportunities using GenAI. So please give everyone a virtual clap with your emojis, please. Are there any questions for Mbasha?
Either everyone is tired or
probably. Yeah. Is there any questions for anybody, or the floor is open for any points of view or anything? There's been a lot of discussion in the chat, but please feel free to make a question anywhere or open up a point of interest.
Okay.
Helen.
Yeah, just in relation to that chat, Sasha, will you keep that transcript from the chat and put it up when you put the recording up? Because there's some really valuable resources in there and lots of great discussion.
I usually don't share chats, but if someone specifically wants it, I'm happy to share it to a specific person and to make it public. So if you would like it, I'll give it to you, but I wouldn't put it public for anybody.
Okay, no, that'd be great if you can send it to me. Terrific, thank you.
Anybody else?
Sasha, me too.
Yes,
Can you send me the chat? Because there's a lot of info in there that I would like to go through a bit more detail. Thank you.
Okay, no worries. Just send me an email and then I'll use that as my task list to remember to send it off. Anybody else? If not, thank you everyone for attending. We held about 50 all the way through to the end, so that's really great. Scott.
Sorry to jump in at the end. I found this session really fantastic, and just wondering if anyone has ideas what topics maybe we didn't look at, or will there be new topics that we're looking at, say, when we do the next one of these in 6 months or a year from now? Does anyone want to future cast?
Sorry, Scott, can you just please repeat?
I really enjoyed this session, and I'm just wondering, with this space changing so dynamically, what will be the new topics that will be added to the agenda like 6 months from now or a year from now if we have another one of these webinars? I don't know what the answer is. Karen?
Well, I'd be interested to hear from people who are making use of things like the University of Sydney tool Cogniti to use AI to build tutoring agents. So I think we can spend a lot of time talking about the downsides of generative AI, and how we stop students from using it to subvert the purposes of assessment. And I think we need to be clear that it's that use that's the problem. But I also know that there are a lot of people investigating positive uses of AI through things like tutoring agents. And so I would be keen, if there's people in the group, to share their use of those tutoring agents. I know there's some investigation at my own institution, but yeah, wondering if there's anyone else who's doing things that could be of interest to all of us.
Like I sneak peeked into my presentation, I'm working on that, and once things get published, yeah, I'll be happy to distribute that information along with anyone else.
And I can see in the chat a couple of comments about thinking about professionals and industry. So yeah, that'd be really interesting to get perhaps an industry speaker or somebody from EA. I know Helen's here, but to talk about that side of it as well.
Sounds good.
So we did a webinar last month, the accreditation webinar specifically on the TAXA, what do they call it? Request for information. But there's certainly, and there's quite a few people who are on this webinar who are on the working group that we've established. So, and my apologies, public apologies to you all that I haven't reconvened that, but we will, and there could be something come out of that. So thanks, Scott. We'll keep that in mind.
Okay, if there's no more, we will close at 12:23, 3 minutes ahead of schedule. Fantastic, everyone. Thank you for attending. All the best for the weekend.
Thank you so much, Sasha. Thanks, everyone. Yeah.